This video is to explain question number 4b on your final exam. This question asked to define all relative extrema to the function g. In order to do that, we need to first consider g prime of x and the critical points to this derivative. As we saw from 4a, g prime of x should equal just f of x. Critical points to the derivative are where the derivative is equal to 0 or where g prime of x is undefined. In examining the graph of f, clearly this graph is defined for all values between 0 and 6. So that's not going to be any issue. However, in examining the graph of f, we see there are several places where this graph is equal to 0, where f of x is equal to 0. On the open interval, this occurs specifically at x equals to 2 and at x equals to 4. Clearly, those two values are critical points, and thus we should or need to examine those two particular points to see if there are any relative extrema at those 2 points. Now, for a relative maximum or minimum to occur, we need to see a sign change in our derivative. Now, at x equals to 2, looking at the graph, we see that prior to x equals 2, right, our graph here is beneath the x-axis, so f of x has negative values. And then after x equals 2, our graph is still beneath the x-axis, so the derivative did not change sign values at x equals to 2, so we do not have a max or min at x equals to 2. However, at x equals to 4, prior to x equals to 4, we see that f of x is beneath the x-axis, so the derivative is negative prior to x equals to 4. And then after x equals to 4, we see our graph of f of x going above the x-axis. So we have a change in the derivative g prime of x, or f of x, from negative to positive at x equals to 4, so that means we're going to have a relative minimum. Be sure that when you write down that you have a relative minimum at x equals to 4, that you state exactly how you know this happens. And again, we can say that we have a relative minimum at x equals to 4 since g prime of x changes from negative to positive at x equals to 4.